Special triangles. What are special triangles? In the world of mathematical modeling, there are two triangles that contain three measures of angles that are used more frequently than any others. These are called special triangles. The first is a 30, 60, 90-degree triangle, or in radians, pi over 6, pi over 3, pi over 2. Here is a diagram of the first one showing the angles and the corresponding sides. Here is the same diagram in radians. Please make a note to add these to your quick reference guide as you will need them as you go through this lesson and more. The second special triangle is the 45, 45, 90 triangle, or pi over 4, pi over 4, and pi over 2. Here is a diagram of the triangle in degrees, and here is the triangle in radians. By looking at these special triangles, you can see that the lengths for the opposite, adjacent, and hypotenuse are given. This information is extremely important in solving trigonometric problems. But how can you use the special triangles? When performing calculations, exact values must be used to ensure accuracy of the mathematical modeling. You can get exact values for the sine, cos, and tan of these angles using special triangles. To do that, let's take a look. Start by filling in this table for the exact values of sine, cos, and tan for the given angle measures. I would also add this to your quick reference guide. And here we have the degree in radians and the sine, cos, and tan. These values have come from the special triangles. I'll give you a moment to just read through and to add them to your quick reference. Here is a sample problem using trigonometry and special triangles. Sample problem. A ladder that is 2.5 meters long is placed against a vertical wall so that the top of the ladder makes an angle of 30 degrees with the wall. Number A, draw a diagram to represent the situation, and then calculate how far up the wall is the top of the ladder. Give an exact answer. Whenever you see the keyword exact in a question, you know you must use special triangles. Here's the hint. Use the values from the special triangles because it says exact. If it did not say exact, you would be finding the approximate value. And that's the decimal value, but you've rounded it off. Draw the diagram. We have our wall, the ground, the ladder from the ground to the wall. That's 2.5 centimeters long, and it makes a 30-degree angle with the wall. Work out the solution. Let us have h to represent the height in meters, which is the height of the wall from the top of the ladder to the ground. Let length h be adjacent to the reference angle of 30 degrees. The length of the hypotenuse is 2.5 meters. So we have adjacent over hypotenuse, which is cos 30 degrees. The length of the wall we said was h, and the length of the hypotenuse is 2.5. Cos of 30 degrees is equal to h divided by 2.5. From the table we made earlier of exact values, we know that the exact value of cos 30 degrees is square root 3 divided by 2. So what we can do, since both sides equal cos of 30 degrees, the two left sides are equal, so the two right sides must be equal. So h divided by 2.5 is equal to square root 3 over 2. So continuing with our solution, h divided by 2.5 is square root 3 over 2. Now we need to solve for h. So we are going to cross multiply. So h is going to equal 2.5 times square root 3 divided by 2, which is 1.25 times square root 3. Continuing on, h is 1.25 times square root 3. So 1.25 is equal to 5 over 4. Now, how did I get that? I converted 1.25 to 1 1/4, 1 plus 1 over 4. I took the common denominator 4, and it became 4 over 4 plus 1 over 4 to get 5 over 4. So h is 5 square root 3 divided by 4. So our conclusion, the top of the ladder is 5 square root 3 divided by 4 meter up the wall. You will learn more in the next video. Stay tuned.